This home has excellent potential to have good indoor air quality and be an energy efficient home. Just need to address a few things. In regards to the samples, I took an outside sample and then one in the master bedroom and one upstairs. The samples on the first floor came back high in a mold called Aspergillus penicillium. This type of mold can be associated with fungal infections, and types of neurotoxins may be released. What was interesting also is that within the first and second floor there were extremely high counts of fungal particulate in the air. So here's a shot of Aspergillus penicillium that's growing on the crawlspace joists and was found also in the living area. But there's also a bunch of debris floating around in the air. They're called mycelia fragments. Outside there was only 5, but inside there was 25 and 36. That's actually quite a few. Regarding the side attics, if they were insulated with a foam material over that fiberglass, it would be better. In the attic, you're doing pretty good. There's just a couple of low areas where the displaced insulation could be put back so we don't have these little hot pockets. Be nice if the air ducts were covered in insulation also, since they are currently of a low R value. Also, there's a main trunk, and that main trunk is not sealed, and the air ducts coming off of the main trunk are not sealed. This is wasting maybe 20% of the cooling that would go into the upstairs by having these joints open. Plus, it's pulling in fiberglass, pollen, and insects from the attic into the ductwork. Also, there's a big gap on some of these ducts that run all the way down to the crawl space, so that causes some cooling and heating of these internal walls. There are recessed can lights. These can lights are a hole in the attic floor, and they should be sealed on the back side so that attic air doesn't come into the home. There's a good filter on the return, and then the return does have a light layer of dust throughout it, and every time the system comes on it puffs a little bit of that, so that's probably why we have such high dust in the air. Some of the metal boots are not sealed to the floor. This is how crawlspace air can sneak into the home. And then inside the ducts, I don't see any mold growth. I do see spider webs, other insects, and construction debris. Some rusting. This is the one in the pantry room, so that would be expected. So no big problems with the HVAC system except that it's filthy. It's been infiltrated with spiders and centipedes, and the system can be cleaned and should be cleaned to improve the air quality. There is a vent underneath the kitchen sink, as you know, and that register is coming off, and inside is a little crazy again with spiders and access into the crawl space. So that's really the culprit here with bugs, is the crawl space is where they're originating from. And then here's a shot where the molding is a little loose and I pulled it back from the floor. The point being is that there's a lot of areas that dust can be collecting in this home, and when the humidity gets elevated there's enough food source for dust mites to grow, and that can also be very allergenic. In the crawl space, we talked about putting a rainwater diverter in front of this crawl space door to help slow down the water from entering the crawl space. This is an open vented crawl space, meaning all the foundation vents are open and there's about 80% ground cover. The ground cover is not complete, so the problem with that is that moisture wants to form underneath it, and then on the sides or on the seams, since it's not sealed, that moisture then can get into the crawl space and raise the humidity, which then makes it easier for condensation to form on the ductwork and the insulation. So underneath the plastic we have a microclimate that's supportive of different types of slugs and snails. And so you're kind of incubating insects down here. There are numerous cave crickets that are throughout the crawl space, kind of hidden up in the fiberglass insulation. They are doing what they do, which is harvest mold and defecate and just kind of make it a smelly place. They are a food source for some rodents and amphibians. Um, this is an extensive amount of fecal matter underneath the insulation. But the mice will work through the insulation trying to find a juicy cave cricket. There's also mold growth on the ductwork. Here's a shot of the supply duct that goes up to the attic, and it has a lot of mold growth on it. The air handler has some leaks, and so crawlspace air is able to infiltrate into the air handler, and that allows mold to grow inside the air handler on this internal insulation, which should be removed because we don't want that fiberglass to get into the airstream. But there's also mold on the coil and the condensation pan, on the walls of the air handler. So whenever the air handler is operating, we're in immediate proximity of mold, and so it's easy for that to get into the airstream. So the mold samples were elevated, but I assume that they go much higher when there's a fair amount of humidity during the summer, because we have so much mold in the air ducts as well as we're able to pull it in from the crawl space. Here's a shot of some of the ductwork inside, and there's just extensive dust and suspect microbial growth in there. The air ducts are condensating seasonally, and so that's causing water to pool on the plastic in various locations and to rust the metal box. So inside this metal main trunk, there's this internal insulation that should be treated. There is mold growth to a lesser degree on the outside of the ducts. That's because of the seasonal condensation, and that can be wiped off. There's a low spot to some extent in the crawl space, but there's no drain, and I'm not able to put one in because it's too low relative to the outside. And if you're going to upgrade to a closed crawl space and pull permit, there needs to be modifications to the water heater.
Here we're in the HVAC system, and we have a loose fiberglass insulation on the back of the panel with extensive mold growth. Inside the unit there's mold growth in the condensation pan, and then in the return box there's dust and looks like extensive growth on the duct liner. Here we have a foil insulation on the side, which is nice, but you can see that it also has mold growth on it. So it tells me that this unit, as a minimum, hasn't been maintained on an annual basis, and it has some humidity issues, meaning that there's water that's or high humidity passing through here that's causing this mold to grow. And part of that reason is the holes that are not plugged, both for the plumbing as well as the filter. Because in close proximity is this mold growth that's on the wood and on the ductwork. So the mold that's in this crawl space is easily pulled inside the system, and because in this particular area there's high humidity, it's easy to take hold and grow. This is an open vented crawl space with an 80% barrier. The barrier is allowing condensation to form underneath, and because it's not sealed, we have insects that live underneath the barrier, and then they're able to come into the crawl space. There's enough moisture where some of the insulation has started to fall, as well as signs of rodents that are displacing the insulation, and looks like some of the rodents are after the cave crickets. This is all cave cricket defecation, and Here's a bunch of cave crickets up in here. More signs of their markings. The air ducts condensate seasonally, and that's why we have the spotty mold growth on them. If this crawl space was to be changed into a closed crawl space and you wanted to follow code, this water heater would have to be modified, as well as the condensation pump. They don't meet code for a closed crawl space. There is some effervescence on the foundation walls, not much. So I'm really not worried about the water pressure. It's there and it's causing the moisture to be higher in the crawl space, but I recommend running a liner down the wall and on the ground and having it be completely sealed. And then there wouldn't be any bugs and no moisture in the crawl space. There is so much sporadic mold that the best practice is to actually take the insulation out so that you can get access to all of the bugs, any rodents, and brush any mold off the wood. And our recommendation is to actually not put insulation back in the floor, but to put the liner on the ground. So you have an insulation liner on the ground and up the walls.
Your crawl space can be transformed into a radiant barrier crawl space in which the temperatures are controlled and there's no bugs or moisture. The process for that is to first remove the insulation and the mold off of all of the wood. You can see condensation forming in that shot. And then once the wood has been cleaned, now we can apply a plastic coating to it. This comes with a lifetime warranty that there will be no regrowth of mold. Next we move to the air ducts, and we're able to wet wipe those ducts with a plant-based sanitizer. So now we're finishing removing the mold from the crawl space. Plastics can be installed as a ground cover. The best choice is to use an insulation blanket on the ground and the walls instead of in the ceiling of the crawl space. Next we install a runner, so we have a mat in the area where there's traffic to the air handler and the water heater. And then as a drying mechanism, we have a one-way duct, so we're able to supply dry air from the HVAC system into the crawl space. Lastly, do a rain diverter in front of the crawl space door so that we're minimizing that water entering the crawl space. And here's an example of what your crawl space would look like when it's finished. Cool, clean, dry, and bug-free. Next, we would follow with an air duct cleaning. Each one of the supply vents would be cleaned by a brush and vacuum technique. Next, we would go into the main trunks and clean that by hand to get the mold off the duct liner. And then we're able to treat that liner again with a plant-based sanitizer and a resurfacing compound. So now you have nice clean ducts at a quarter of the cost of replacing them. Lastly, up in the attic, be advantageous to seal the can lights so that air from the attic is not able to move into the home. That's also a pathway for insects. So in regards to the can lights, there's a simple box that goes over those lights, and then that box is sealed and then covered with fiberglass insulation. And then all of the ductwork, there are some methods for sealing them that will greatly help to heat and cool the second floor. The air ducts where they connect into the ceiling, this is an example of them being sealed. The side attics, there is a heat load against those side walls, and you have a fair amount of that wall, so I think this has a pretty hefty burden on resisting the cooling of the second floor. So here's a shot of what the foil looks like, covers the fiberglass insulation. makes for a nice storage area. If you decide to go on all surfaces, then it becomes a tighter environment where there is not any bugs or pollen. Thank you for the opportunity to be of service.